So last week, which was Section 3, Week 1, we had covered two main topics in our videos. We had covered this destroying objects. So basically, that time delay, how to click the clear button, how to right click, and then I went into building the clock. Just the geometry of it, not how to like write the script for it. And so building the clock is all connected here. This clock tutorial, which is here. This guy's an excellent developer, great teacher. So take your time with it. I asked you to move through this first part. After I built the clock, I asked you to do it yourself. And he covers a lot of intro to Unity stuff that'll help you get grounded in material in addition to my lectures. I went through, starting right here, I kind of went through all the steps you need to take with building this clock. And some of the big areas to understand was how to use like empty parent groups to build all these clock indicators. Like you don't manually build them. You take the geometry and put them underneath a parent that's centered up in world, and the child is up here, and then you duplicate. You can just rotate every 30 degrees and keep like duplicating out each hour indicator. And because it's rotating from the center, and each hour gets placed like perfectly with position and rotation. And the reason that we did 30 degrees is that the clock face covers 12 hours, and a clock face is a circle composed of 360 degrees. So if you divide it by 12, you get 30 degrees per hour. And so I was introducing you to like this trick of using like empty parents, empty game objects, and you drag the others underneath it, and it gives you like this rotation offset based on the positions of the parent and the child. And then I did the same trick for the hour, minute, and second hands. If you just built the geometry, if you just rotate it, it rotates right about the center point when you rotate the game object. And that's not what we want to do. So we did a similar trick where we had an empty game object and just positioned it at the dead center of the clock, and then moved the hour geometry underneath it. So when you rotated the parent, its center point, its pivot was different, it was offset, and the clock hand rotated about the center of the clock. Then we built the hours, minutes, and seconds hands, and we talked about the materials. We talked about the standard shader, which we used a lot, but we were introduced to a new type of shader, the unlit shader, which is a simpler shader that we made a material from it. And we just were able to apply some basic colors to the clock without the clock having to be dealt with the lighting source in the scene. Just it's unlit material coming from an unlit shader. And I stopped there, and then this is where we're going to continue in class. We're going to continue about building the script that makes the clock animate. It's going to grab this time from the system, from the operating system, and we're going to figure out how to rotate those hour, minute, and second hands, and then do some additional features that deal with the clock time. So our click detector script, this was the section where it was right click to delete. So we're checking if the user's right clicking in our update loop. We're creating an array, basically figuring out where the mouse position is on the screen and drawing a line or shooting an array out into the world with the physics system to see if we hit something. So to be able to hit something, that other thing needs to have a physics collider. So if I unclick time and just paint all these spheres that I'm painting, notice they have a collider, and that's how we know for clicking on it. And then the clear button we also covered. That's down here. This is a public method that the UI event system is calling. So when the user clicks that button, we said, hey, call this public method. And we did a for each loop. And for each loops like our simplified for loops. and they're like looping through all the transforms that are right underneath the current transform on our click detector that's sitting here. This transform, we create all our content underneath it. They'll have transforms, so we loop through them with the special keyword in, and we destroy them, but not the transforms. We have to go up to the game object, the larger game object, and destroy it. And since we're covering for loops, I wanted to cover, let me cover something that's more fundamental, the for loop. And you have to like specify out each part of the for loop to get it to work. And it might help you to understand what's happening before each loop more. So you have to specify an iterator, a variable that will be changed, iterated, and it's a statement. Then you have to do a logical check, be like, wait, whatever I'm iterating, is it some true condition? So in this case, is it less than the amount of the size of the collection we have to move through? And if so, we do the logic. In that case, go into the current transform, go get me a certain child, which is a transform as well, go get me its game object, and let's destroy it. And then we iterate the iterator. We update it. In this case, we're just adding 1 to it, and we're running the process again. All right, I'm just going to comment that out because the other one was active right now. And once we went over those last parts of the kind of the current code base, we talked about building the clock. So it's a lot of pieces of geometry at the top, just to transform to position it. And then we're going to start to build this clock script, which I'll cover later. This is at the top. But we had the big face, the big piece of geometry right here. Has an unlit material. So differences between standard and unlit. And here's the clock face. And here is our hour indicators. And something to note as I'm moving through them, just notice that the Y rotation is changing by 30 degrees. They'll have unique Y rotation as they move about the clock face. We're going to use that information later. And they have a collider on it. They all have colliders because we're going to be checking if we're clicking on them. And they're on a different layer, which we're actually going to get to this next week. And then we have the hours arm. Which, remember, it's an empty group that sits in the middle of the clock, and it just helps us to accurately rotate the arm that's underneath it. And so if we rotate, so we can test the different, so it looks like Z isn't what we want. Looks like X is not what we want. It's going forward, backward. And in this case, it looks like Y is what we want. In this case, positive Y, to figure out how we should rotate this or animate it. So if you notice, I do 30. It's going to be like 1 o'clock, and 60, 2 o'clock, and 90, and so on. And that's how we're going to actually animate our clock in a bit. And these are empty parent objects that underneath is the geometry, and the colliders are disabled. You don't want to use them to interact with them. They're just more passive elements. And with that, I am going to jump into the clock scripts. So there's 2 scripts, and just the way I was building this in the class is this one basically covers that second half of the tutorial. So this tutorial, like moving halfway down, how he ends up writing his script and getting the clock to animate with system time. That's this first script. And then I'm going to cover the next script, which gives us some additional features that are unique to this painting app. So notice that we got our using statements, some namespaces. Notice that we're using UniEngine. It's highlighted. That's because we're inheriting from mono behavior, so we are using some code from the UniEngine namespace. But notice now using system is now highlighted. We actually will start using some classes from the system namespace, and particularly this date time and this time span. And that's how we're going to read the time from the operating system, the date and the time from the operating system, so that we can update our clock. And so we just have our class name. It's inheriting from MonoBehavior, from UniEngine. And this section here is going to be our properties. And these are properties that some of them we're going to set in the inspector, and but all of them are useful in all of our methods in this object. And down here, notice we have an awake function method that's coming from MonoBehavior, and the update method that you are familiar with. And we just have some helper methods down here. So some of the properties that we're going to start off with are some transforms. So we wish to animate the hours and the minutes and the seconds, that group, the parent group. And so if we're just animating, if we want to like just update properties on the transform, let's just say that we're going to grab the transform. We're going to make these public. You can make a private with a serialized field. But we are interested in getting the transform and not the game object. So if I come over here, remember that the game object is like the big housing container, and the transform is one of the components. It's a very important component. It's a required component, but it is just a component. But we are going to reference the transforms directly, as we see here, because we're just going to update the rotation on them. Here we have some floats. Degrees per hour, degrees per minute, degrees per second. So if I figured out like, oh, the clock has 360 degrees. So if there's 12 hours on a clock, each hour should take 30 degrees. That's how the 30 is there. And minutes and seconds, there's 60 minutes and 60 seconds in a full rotation. So if I just do the same type of math, I see that there's 6 degrees per rotation. And so that's how these numbers came about. And we are dealing with the day cycle, but the light moving, but I'm going to cover that later because it's just too much at once. Let's just focus on the hours, minutes, and second hands. And notice that it is a constant keyword in front of this. So all of these declarations are going to be of type float. They're going to be private because we didn't declare it private or public. And they'll be of type constant. And constant just means you can't edit it later. So you must declare it, and then you must assign it a value right away. And then once you do that and you declare it a constant, you can never change this. So it's super useful for like math constants or things that you know. In this case, like I know that there's 30 degrees in 1 hour. That will never change. So I declared a constant. So I don't accidentally change it. Now I'm declaring a date time variable, and notice as I hover over it, it says this is a read-only struct coming from the system namespace. So these are read-onlys because we're querying the system, the operating system, and it's saying, well, here's my current time. There's no point in editing it because these are the time values. Now there are structs. Remember the difference that a struct in a class is very similar. It's still like a C# file, and an object still gets created from it. But a struct is a little bit more limited in that it can only have properties. It can only have data. It cannot have methods associated with it. So that kind of makes sense. Like this thing is just going to have a bunch of data or fields talking about what the date and the time is. The hours, the minutes, the seconds, the day, the month, the year. And that's it. You can just read it. And if I go to time span, similar thing. It's a struct coming from the system. Namespace. And I call them discrete and continuous. And I'm just showing off that there's different ways to get the date and time information from the system, and they come in different formats that you might find useful. And so these are some bools that we could turn stuff on and off for testing, and I'll show you what they're doing. But we're testing, should we want a continuous time, or do we want to like mess around with real time and, for other testing purposes? And then I end up doing the transform of the day cycle. That light, I'm going to cover that later. So let's just talk about that later. And same with this. This is for testing. This is how do I change the hours in the day to see if all my systems are working. And note that a day has 24 hours. So even though we're used to convention of AM, PM, and break it down to 12 hours, like 10 AM is 10 hours into the day, where 10 PM is actually marked as, what's that, 2 hours before midnight. So it's marked as 22 hours. So like 1 in the afternoon is actually 13 hours. So we're going to have to handle that later. Now, the awake method is very similar to the start method. So start, awake, and update. It's all coming from mono behavior. And they're all have interesting use cases at runtime. We've seen the start method, and it's run once right away when the runtime starts, when the app starts. And it's usually used for initialization. You know that we're starting up. There's a bunch of values we have to set. Awake is similar to it. And sometimes, in this case, we're using wake for initialization. Now, awake happens every time that the object is turned on. So sometimes it's useful to turn stuff off and turn stuff on during runtime based on certain situations. And when a script object gets turned back on at runtime, awake will be called. So start can only happen once throughout the entire runtime, and awake under this simple situation happens once, and it's acting for initialization. It's acting when that object first becomes active. But awake is also helpful if you have to turn stuff on and off your script objects, and when they come back on, they become awake. So awake can be called multiple times during a runtime based on if the object's being turned on and off. And then we have our update method, which we're used to, which is called as many times as possible, basically for each frame during runtime. So for this awake method, we're going to use it to initialize our clock object. And what we're doing is we declared this time discrete variable up here to type date time. And we're going to go into the datetime class, and we're going to call the now property. So this is a static property. It's being called right on the class, and it's going to return a struct, a datetime struct that represents now. So it represents the date of now and the time of now, which is November 10th, 2023 at 2:56 p.m. And we can go into that datetime object. We can go into one of its properties called time span, and this is going to be a time span struct object, which we see up here, and that's for going in, and we can get data just about the time. Just we can go grab the hours, the minutes, and the seconds of that we're currently at. So if I hover over hours property of it, you see it's just an integer. So right now it's 2:56 p.m. So it's 2 hours past noon. So it would come back as 14. So notice these three lines. We're updating the rotation of our hours, minutes, and seconds transform. And we're going to ignore this for now. We're going to come back later. But let's just look at the hours transform. We're going to grab the local rotation. We're going to set it. So if I come back to hours arm, this is the rotation property. This is what we're going to set. All right, we're in this transform, and based on how I'm moving this, you can see I want to move it positive y every 30 degrees per hour. So we're doing local rotation because it is inheriting some rotation from the parents above it. For example, I like positioned and rotated and scaled the parent so that it looks really nicely and aligned with our UI. But I don't want to deal with these rotations. They're a level up. They're like part of like the global rotation of this object. I don't want to worry about it. I just want to worry about the local rotation because it's nicely zeroed out and it makes for easy math. So that's why it's local rotation. And what are we doing here? Okay, so if I hover over rotation, you see that it's of type quaternion. So the position is a vector 3, which you've been involved with. The scale is a vector 3, which you've also been involved with. These are just 3 floats, easy to do. 3D rotation is actually more complicated. And there's some complicated math that we're going to luckily not have to get involved with. We can ignore it. It's wrapped up in a class, which is called a quaternion. And we can call a static method on that quaternion class called Euler. So Euler angles are something that we're more familiar with, that are easily for us to understand. And that is the convention of 360 degrees about a full rotation. So notice that it just receives an X, Y, and Z, and it will then create a quaternion that we can use. So it's an easy way to create a quaternion. And as I was just moving the hour hand, you notice that I don't care about the X and the Z. I just want to update the Y based on the time. So that is why the X is zeroed out and the Z is zeroed out. And we're doing some math to figure out how we should rotate this clock hand in the y-axis. So we're taking the, remember we already grabbed the date time dot now into this variable, and we're grabbing the hour, which is an integer. In our case, we're just about to turn 3 p.m. So it'll come back as 15, and then we're multiplying it by the degrees per hour by 30. So we're actually going to rotate in this situation past 360, but once you like rotate past 360, you're like back to where you were. So let's just think about a simpler use case. Let's think about 3 a.m. Okay, 3 times 30 is 90. So if I click play, let me just, I don't want the clock to run right now. I'm just going to put a return statement here in the update because I just want to run this awake method. And I'm going to click play, and notice that our hours arm has 90-degree rotation, 3 o'clock. And so 3 a.m. is 3 p.m. is 15, and just think of it as like, well, we did a full 12 hours becomes 360, and we come back to point 0, and then we go another 3 hours. So that's how we rotate the hours hand. And the minutes is going to be very similar, except we're grabbing the minute property, which is again an integer, whole minutes, not fractions of a minute. That's why it's discrete time. And we're multiplying it by degrees per minute, which is 6. We just happen to be at 301, so it's not gonna, let me reset it and you'll just get a 6-degree change on it. So notice it's just 6 here. And notice that the hour hand is just slightly, but the seconds, it happened to be around 30 seconds when I clicked play. So that's why it says 180. But that's why the seconds is the same calculation. All right, so we have hours, minutes, and seconds that we updated. I'm going to ignore the day cycle for right now. And we're just storing in our hours. Like whatever it was, just store it because I'm going to like do testing and stuff later. Now we have to go into the update method and how that's working. And then I have to cover what this day cycle is all about, how we're going to manipulate the big sun in the sky. If I zoom out, where is it? I lost track of it. Hold on. He's like hiding. He must be like, let me see. The sun must be, that's saying it's right. Okay, there it is. It's at dead noon. It's right above me. But you can, we're going to animate it so that, like, based on the time of day, we're going to move the sun. Then I have to cover the AM PM button. I'm going to stop the video now.